Capturing the keyboard input on the computer allows for a different form of interaction. Capturing the mouse is what we've done so far. Capturing the keyboard is quite fun because we can now build little kind of on-screen interactivity based on using input from the keyboard. So you can press any character on the keyboard and we're able to keep track of what character has been pressed and then make something happen because of that. So I would argue is really cool. Disadvantage, of course, is that it requires a keyboard. So if you start thinking about if we're trying to build some sort of interaction or interactivity for a device that has a touch screen instead of a keyboard, suddenly this doesn't work quite as well because we don't have physical keys to press. So if I'm making something for an iPhone, iPad, Android device, or Samsung Galaxy or whatever, I don't have a keyboard necessarily, which means it becomes much harder to now track what input the user is providing. So then what we're really building is something that's geared for an actual PC, for a laptop or a desktop styled computer. And that's, of course, you were to, say, have a tablet like an iPad with an attached keyboard or Windows Surface or something like that. So all of the keyboards generate ASCII input, ASCII character code. So every time I press a key, it generates a key code that we're able to now gain access to when we're listening for it. So we tell our program, hey, listen for the key to be pressed. Oh, by the way, what's the code of the key that was pressed? And then once we know that key code, we're able to do something with that. So under text input 2, what it does is when you press a key, it now modifies the text that is currently on screen. And if you press the mouse, then it will now change the text to the key code of the last key that was pressed. So we can actually start to learn what numbers are associated with the keys on the keyboard. So running this, it will make more sense once you actually see it run. So it asks me to type something. So if I press, no key has been pressed, oh, it doesn't. Now if I press the A key, let me delete, I'll press A, now press the mouse, it tells me, oh, the character key code, actually I gotta be careful there. There's character codes and there's key codes. They're a little bit different because one takes into consideration capitalization and one just worries about what physical hunk of plastic you're pressing on your keyboard. So is it the character or is it the key? What key did I depress? Or what character am I generating, such as lowercase a versus uppercase a? In this case, we are now looking at, now if I press B, you'll notice, oh, wrong. If I press, let me try again. B, and now press the mouse, we see, okay, that's 66. Now delete, press C, press the mouse, 67. You may notice there's a little pattern going on here. A was 65, B is 66, and it goes all the way down through the alphabet that way. So it works out pretty well. Now, keys that are interesting, I press the left arrow key. Well, there's no visual representation for it, so it shows me the little box, meaning I don't have a character to show you. But now if I want to know what key code is with the left arrow key, it happens to be 37. If I press the right arrow key, it happens to be 39. So looking on your keyboard, you'll see where the arrow keys are. So I'm going to start again with left arrow, 37, up arrow, that's 38, right arrow, 39, down is 40. So if you go around clockwise, starting with the left arrow, it's 37, then up is 38, right is 39, down is 40. These are the ASCII character codes that those keys generate. These key codes are accessible in all of the programming languages that you use to interface with the computer. So you can, anytime you have a keyboard and keys are being pressed, it's generating these key codes. So no matter what language you're writing in, you can now go find what these standard numbers are that are associated with the keys on the keyboard. And that is a very useful thing because it's possible to now remap a keyboard for different languages, but we have to know what physical key is being pressed and react accordingly to that. So with this, if I press the left arrow key, the key code for left arrow is 37. And we will be using that because we're going to make a little vehicle that we can now move around on the screen. And maybe it's not, yours won't be a vehicle, maybe yours will be a little critter or a character or monster or whatever you choose to make, or a circle because you're like, no, I don't like rectangles. You're a boxist, you don't like rectangles. You like things to be round and pretty. Who knows? But we're going to now use these different key codes at our disposal. Now what's happening in my code is I have my key press function, and now it's doing a little bit more, so it's controlling the text that's showing up on screen. But you'll see there's repeatedly the word key code is showing up here. So we're saying, hey, if the key code is backspace, and if the length of my text screen that's on text string that is on screen is greater than 0, meaning there are letters that we can see on screen, then what it does is it now cuts off whatever the last letter is. So when I hit backspace, it gets rid of the last letter. If I'm on a keyboard that can differentiate between backspace and delete, one which if you're on a Windows keyboard, instead of seeing delete twice like you do on a Mac keyboard, you see backspace and delete as your key options. So then it corresponds to that. And there are a couple keys that in processing they have now, instead of using the number representation for the key code, they've also assigned a string constant like backspace, like delete, shift, control, alt, versus just specifying the number, so that when you're writing your code or programming, it's a little bit easier that you don't have to know what those keyboard numbers are. Other languages aren't always so friendly, so you can take and map to words like this so that it makes it a little bit easier to program, so that you can say, hey, if left, meaning you press the left arrow key, or if right. And processing does understand that, but we're going to use the numbers today to get used to that, because many times you will run into situations where you're forced to use numbers and you don't get to rely on just using nice pretty word representations for whatever the key code is that was pressed. So we're going to explore that in a little bit. Now the key is the value of the key that was pressed. So if I press the A key, the B key, the C key, it actually adds that letter. But the key code is the ASCII number representation for whatever key has been pressed. You've been provided with the shell file. It's got some of your variables set up. It has the vehicle class set up. But the vehicle is now missing update and display information. And we're not capturing the keyboard input information yet. But otherwise, I think this runs. Yeah, so it runs and does nothing because there is no actual data inside update or display, and there is no, it has the functions ready for key press and key release, but they're not doing anything yet. So that's where we're going to start. So we're going to work inside those functions. So the way that we can do this is we can now press the key and make something happen, where we could say modify the position of the object. And I'm going to just put some stuff in. Don't copy along with us, because this isn't just, I want to show you why we have to do something a specific way. So just going to fill my rectangle, and then so now I'm displaying my rectangle at its width and height. I did leave display open because on your particular samples that you're working with. If you want to fill display with something else besides just the straight rectangle, I would encourage you to do so. If you again, if you don't like rectangles and like circles better, go nuts. I don't care. I'm not offended. It's all good. But under update here, now what we want to do is start modifying this. So now if I run this, we should see a rectangle on the middle of the screen. Okay. So the rectangle shows up at the middle of the screen. Now if I press a key, if I were to say v dot x plus equals, oh, actually, well, we can just leave it that way. It'll work. So if I press any key in the keyboard, I'm going to add to the x position of my object. Now, what we need to, and now you may have noticed it's a little bit chunky. I think I'm going to just fill the background. So it doesn't leave the trail of cars behind. I'm going to speed up that quantity. Now when I press the key, so I can press any key. I press a key. So you'll notice it's moving in a fairly chunky manner, 1. But 2, there's a delay from when I press the key. It moves once and then pauses for a little bit, and then it starts going. And what's happening here is when I press the key, that generates a character. And then there's a pause, and then it starts repeating that character based on my system preferences. Not based on my kind of frame rate of my game or the speed of the process or anything else. It's based purely on my system preferences under keyboard, delay until repeat, and how fast do I want the key repeat rate to be. Now, some people on their computers turn those settings way down because they find they have heavy fingers, so they leave their fingers resting on the keyboard for a while. So they make the delay long, and then they make the key repeat rate really slow. So when they do that, if I run it, you'll see, press the key, waiting. Oh, and look, now it's chug, chug, chug. Okay, so if I'm at the mercy of the system preferences, and now we'll make the delay long but the repeat rate fast. If I'm at the mercy of these system preferences, it really does create pretty pathetic play. So, and then it takes off. So if I'm trying to build some type of interactive where the user has to actually move around and do things in a relative timely manner, like catch objects or avoid objects, that's not really going to be a satisfactory way to play. And you will find that you will grow frustrated, and anyone else you have sit down to play your interactive will grow frustrated. So that's not how we want to do things. The good part is we have better ways to do it. There. So we're not going to do it that way. Instead, what we do is when a key has been pressed, we say if, and we're going to learn a different way of writing if statements this afternoon that will be more efficient than what we're doing here, but I'm going to work with what we know first and then revise how we're doing it into a different programming technique. And in this case, it's a technique that is very commonly, it's used frequently for this, and it's just something that would be good for you to know. So if the key code is equal to, and we remember that the left arrow is actually, well, okay, yeah, we'll do left arrow first, is 37. Oh. So if my key code is 37, at that point, what we need to do is say left is equal to true. you will notice up at the top of the document there are 4 booleans, left, right, up, and down. So what we're going to do is say, hey, if the key code is 37, we want left to become true. So we're setting that up. So right now, if we can get one direction working, that's going to prove to us that we can get all of our directions working. So now what I can do is say if, under update, inside my vehicle, if left I'm just going to undo something else. Now, when you have very simple conditional statements, it's actually possible you don't have to put all your curly braces on multiple lines. So you can put them all on one line if you want. Again, that's a technique that we can do. So we can say, hey, if left, do that, and then x plus equal speed x. Okay. And because I'm going to slow it down just a touch, because otherwise things will happen quickly here. It is, I press left and, oh, shoot. So when I pressed left, my speed x became -2. All right. So that's great, but we don't have any way of kind of undoing that. But what we really want is if left, so if left is true, we want our speed x to be -2. But if left is false, we don't want it to have a value. We want speed x to be 0. So we want to start to slow it down, to kill it. And this is where things start to get a little bit more interesting. But how can we make left become false? The same as having a key pressed function. The key pressed function, when I press it, it generates a key code for whatever key was pressed. But I also can generate a key code for whatever key is released on the keyboard. So in the same way that we can say, hey, if the key code is 37, left is true. I'm just going to copy that, put that down here, and then say, hey, if the key code was 37 on whatever key just got released, why don't we set left back to false? So that now makes left become untrue. So that's a good thing. It gets us off to a good start. So when I press a key, it becomes true. When I release that same key, the Boolean I'm associating with that becomes false. So it's getting me set up to be in a good position. So now, if I run this, if I press the right arrow, the down arrow, up arrow, space, nothing. If I press left, it takes off. And it's still going. And still going. And still going. So we turned it off, but we know where, once we set speed x, we never put any code in to kill speed x. And if we say if not left, if I say if not left using the exclamation mark, and just throw a few extra returns so it's higher on the screen. If I use the exclamation mark here, that's saying not left, or if, I could also say if left is false. It's the same. Left equals false if I'm comparing left to false, that's the same as saying not left. So if not left. So I have left and not left, or if left is equal to true, or if left is equal to false. Those are all the same way of doing things. And as you go encounter other people's programming code and try to Frankenstein it into your projects, you will at times see where they will compare to a true value or a false value, and other times you will see where they use the exclamation mark of true, and this is now saying, well, when this value is false. And we read that, if we're trying to read the code, we say if not left. That's how it's read out loud. Oh, wrong key there. So now when left is not true, we want to set speedx equal to 0. So now if I run it and press the left key, go, stop, go, stop, go, stop. Hey, pretty exciting now. If I press any other key, nothing happens yet. So what we can do at this point is we can start to look at how we can add in some of the other keys. And this is where I want to introduce the concept of a different way of writing in if-else statement. Because we say if this, and then we could say else if key code is equal to, I'm going to just work with left and right now for simplicity's sake, and it'll become apparent why shortly. And again, you will notice this is highly repetitive between the key press and key release, the only difference being all your trues become false values. Now, change my lefts to rights. And then change that to a positive value. And there's no harm in writing it this way of -2 +2, even though it's on this side of the equal. That will give you a decent result. We can run it. See, I'm pressing left arrow. Oh wait, right arrow works and left arrow is now dead. But I knew that. That's going to happen. There's a couple ways that we can now take care of the brokenness in our code. One of those is that we can get rid of that right there, and we can say if not left or not right. Sorry, no. Needs to be and not or. So if not left and if not right, meaning I'm not pressing one of those two. Because if I press left, then if I press something else, I'm still pressing left if I haven't let go. But once I let go of left, left will become false. And then that won't override right. But if I press right, not left, then I won't get to 0. But if I'm not pressing either one, that means they either started at false or I've let go of both of them to set left and right back to false. So my speed will, in fact, die. Left works, right works. Right does override left. There are a few things we can do that we can counteract that. But generally, though, it's not the end of the world to have one override the other. But another possibility is if we're running it, if I press left and now I press right, but I never let go of left, that means they're both going. So if I press both, we could make our speed die just as easily as saying if I'm holding down neither one. But that's minor. Getting it to work with up and down after this would be a much more pressing issue. But again, this chunk up here in our key press and key release is kind of ugly. It's not pretty. And it'd be nice to have a little better representation for this. And the method that we're going to introduce for this is referred to as a switch statement. A switch statement is simply another way of writing a conditional where you're checking for multiple things. So I'm going to leave what's there for the moment so we can compare. But what I do is I write in switch, and then I'm switching based on the key code. And now there's some kind of a little different syntax than we may be used to. We use the word case, and then we specify what we're looking for. So on the case that I have now pressed 37, and then I put a colon. This is really important that I do case, the value, then I do a colon. Then on my next line, I specify what I want to have happen. I want left to be set equal to true. And then I now need to say break. Break will make more sense once we put some more code in here, and then I'll be able to explain it, but right now it's not really going to make a lot of sense to explain it. Case 39, right equals true, break. In the most strictest and proper syntax at the very end, we specify default, and then you specify what you want to have happen. Nothing. And that is now doing a switch statement. Now what you will notice is there's a conspicuous lack of curly braces. So if we look at the if, else if statements, we have all kinds of parentheses and curly braces up the wazoo. In a switch statement, we don't. So in something where we're just checking a bunch of key codes, most resources you encounter are going to end up using a switch statement versus a series of if-else statements, because it will make more readable code. So I'm going to finish writing out up here using the if-else if. So you don't need to do that, but I'm going to do it so we can see just how ugly it gets. Oh, I don't know why I typed it when I could have copy-pasted a whole bunch. No, not yup, but up and down. So if, else if, else if, else if. And when you're writing a if, else if, it's not a bad idea to then even have what would be our default case of, else, what you want to have happen when, everything is broken. In this case, we're just going to say nothing. But so here I've written it with a bunch of if, else ifs. Now, writing a switch doesn't necessarily mean we're using less lines of code, but I would make an argument that we're using easier to read lines of code. So here's the switch statement, so we can see it on screen. And here is the if-else if statement. And I think it's easier to read the switch statement. The tricky part is you have to remember the syntax of how to organize it, what punctuation marks you have to use, and crap like that. But it is, when you have lots of things, so now imagine we're not just doing 4 directions, but maybe I'm tracking a dozen or 2 dozen keys in a very complex interactive. This, with that, could get rather ugly. This makes you get neater columns. All of your columns line up. It spaces things out, I think, a little bit easier. It's just, I think, a better way of doing it. Now, switch statements don't work in all instances, depending on what you're trying to do. Within processing in Java, you can only do a switch statement with constants, so it has some there's some caveats of what we can do. JavaScript and ActionScript are a little more flexible in how we can do our switch statements, but I think they are. One thing that I did not talk about and said I would get to later is why we type the word break in here. If I do not put break in here, what's going to happen is, so if break is gone, so I set a value or do something with the value, the next thing that happens is, oh, well, then that's correct, but then it goes through and it moves down to the next case and says, oh, well, that's, I guess, what you really wanted. Oh, no, maybe you wanted this one, and it goes and it chooses the final thing in your case statement or your switch statement. So if you forget to put a break in, it will now choose whatever the last item is and make that now the thing it does. It's important that you remember to put your breaks in when you are doing a switch statement. If you don't write switch statements for a while and you're like, oh yeah, some person told me I'm supposed to use switch statements when I do this, so I'm going to do it, and then you forget to put in your breaks and then it doesn't work and you're like, well, that was stupid. I'm going to go back and just write if-else ifs. You can use if-else ifs and it's just fine. I just find in something that is highly repetitive like this, where we're just assigning certain values with some booleans and other stuff, that the switch statement is generally easier to read. So your mileage may vary. You can decide what you want to do, and both are right. So I'm going to get rid of the ones that I don't care about. There, so now it's all switch statements because today is about switching things up. Bad joke, sorry. Now it's moving and it's going. Now the next thing that would be nice to include in this, and then we can say this example is wrapped up and then you get to turn it into something super awesome and cool and exciting, is, well, when I hit one side of the screen, it would actually be nice if now maybe I landed back in the other, so I have this, like, I'm just wrapping. If I go off the left side, I reappear on the right side, so I can, instead of disappearing into the nothingness of space. So it works like the classic video game Asteroids, where if you fly off one side of the screen, you reappear on the opposite side, top, bottom, left, or right. And I think that makes it kind of more fun that way. Otherwise, we have to know where we are once we're off screen. So to accomplish that, once again, we'll have to just do some ifs in there, and then it's no big deal. We can say if x is less than 0, meaning I've gone off the left side of the screen, at that point I could simply say x is now, I'll assign x equal to the width. So now I'm off to that other side of the screen. Now, if you want to do these statements on multiple lines where your curly braces are on different lines and it's all nicely organized, I encourage you to do so. But if I keep mine single-lined like this, it will be a little bit easier for you to see everything on screen, since this involves a lot of curly braces. So if my x is now greater than my width, meaning I've gone all the way to the other side, at that point I want to say x is equal to 0. And now we get to repeat that for y. So if y is less than 0, meaning I've hit the top of the screen, then we can simply say y is equal to height. And if I say if y is greater than height, then I can say y is equal to 0. And that will now create the boundary wrapping. So when I hit one side of the screen, I bounce over to the other side. So I create this perpetual. And we did this where we used our little check bottom function before, when our drops in the catcher game hit the bottom and then we put them back up at the top of the screen. So we created that perpetual wrapping. We can now do that with our vehicle here, that object that we're controlling. So if we now run this and check it, we should see that it now allows me to move my object. So if I go up, yep, it's wrapping. If I go left, it's wrapping. Right, wrapping. Down, it's wrapping. So we can now create that kind of movement style that we get in the classic Asteroids video game.